This is question number 2 from the SACE Stage 2 Physics Course Companion from Subtopic 2.3 and 2.4, which are combined in the textbook. Here we have a current carrying conductor producing a magnetic field of magnitude 540 microtesla at a radial distance of 2.25 millimeters. First, we're required to use proportionality to determine the magnetic field strength when it's 9 millimeters from the conductor. So here we have the 2.25 millimeters going to 9 millimeters. So we have that the radial distance is going to 4 times the radial distance. Now for proportionality, it's done a little bit differently to this normal straight calculation. So since we know that B is mu naught on 2 pi multiplied by I on R, we have that the magnetic field strength is directly proportional to 1 on R. Therefore, our magnetic field, since the radius is increased by a factor of 4, will go to 1/4 of the magnetic field strength, which we can just calculate easily as 1/4 of 540 microtesla, which we can substitute into our calculator to get 135 microtesla. Next, we need to calculate the current in the conductor. So this is just using the formula but rearranging it. So as I said before, we have B equals mu naught on 2 pi multiplied by I on R. Now this can be a little bit difficult to rearrange when you have this constant mu naught on 2 pi. Sometimes it might be a bit easier if we just substitute the value for that before we start rearranging. So we know that is 2 times 10 to the power of minus 7 multiplied by I and R. Now it's much easier to rearrange, so we can just rearrange that simply enough. So we'll have I equals B times R on our constant. And now it's just a matter of substituting the values in. So we have from the stem of the question, B is 540 microtesla and R is 2.25 millimeters. So 540 microtesla multiplied by 2.25 millimeters all over our constant, which if we substitute into our calculator, we get approximately 6.1 amps. After that, we need to determine the radial distance that produces each of these magnetic field strength values. So the first one is 230 microtesla. So here, all we have to do is rearrange our formula again for R this time. So we have B equals mu naught on 2 pi multiplied by I and R. Therefore, we can get R on its own. Then it'll just be R equals mu naught on 2 pi multiplied by I on B. So for the first one, we have 2 times 10 to the power of minus 7 multiplied by the current, which is, oh, we just worked it out before, that was 6.1 amps, all over the magnetic field strength value. So for this one, it was 230 microtesla. So 230 microtesla, which if we substitute into our calculator, we get 5.28 times 10 to the power of minus 3 meters, which is just a bit nicer if we write it as 5.28 millimeters. For the last part, it's the same sort of calculation, except we have a different magnetic field strength value. Here we have B is 340 nanotesla. So it's the same rearrangement. R equals mu naught on 2 pi multiplied by I on B, which is 2 times 10 to the power of minus 7 multiplied by the 6.1, which we calculated before. But this time we have the 340 nano. Now nano is 10 to the power of minus 9 Tesla. Substitute to our calculator and we get 3.57 meters. And that's it. That's not too bad. The formula is pretty simple. The hardest bit's really rearranging in terms of mu on 2 pi, that can be a little bit confusing, just like rearranging using Coulomb's law. But if you substitute the constant value first, it becomes much easier and a fairly straightforward question after that. And that's it.